Every Earth Day, we're reminded to be a little more eco-conscious with the choices and purchasing decisions we make. With a smart thermostat, making some of those choices a lot easier. Being more eco-conscious with the way you run your household and manage the temperature becomes a lot easier. And we've incorporated some different elements into it in with the software and hardware side to make that a reality.
From here, I'm going to turn on the thermostat with my laptop. You can hear the fans. And as you can see, the red LED light is on, indicating we are in heated mode, as well as with fan. Here we have the little control system. It's getting all of my temperature values for the thermometer, as well as some predicted temperatures for a mathematical model, which I'll discuss in a little bit. Okay, this is our control center. We can see the current temperature, the outside temperature, and the current heating modes for the device. We can raise the temperature. We can also lower it, which will change the heating modes. Below threshold, you can just hear the AC compressor turn on. So now that we are actually cooling the apartment as opposed to heating it. Further here, we can see a few plots. These are examples. We have all the data logging things set up. We haven't had enough time to generate real data here, but it's looking at two different things. One is temperature and one is R value. Temperature is just the temperature apartment. If you like data, you can see how it's changed over time. The more important thing, and the thing that I spent many hours programming my mathematical model, is the R value. The R value is the thermal resistance between your apartment and the outdoor world. It's a coefficient of heat transfer, and the heat transfer is proportional to the difference in temperature inside-outside. So the higher your thermal resistance, the more well insulated your apartment is. So we had this idea, what if we could figure out the R value at any point in time? That way you could actually see how you're doing, and you could change your you could change your habits before you actually end up costing all of that energy. So if you open up a window, your R value is likely going to decrease, and you'd see it on the graph before you had to actually pay it on your energy bill.
The inside, outside, and
The temperature control system, the HVAC system.
Okay, don't worry. I'll just cut through.
what
I'll cut through.
Okay.
You can just say something like, we built our smart thermostat to do more than just schedule. I don't know. It's not appointments. What do you say? Schedule temperatures.
Yeah.
We've built our smart thermometer thermostat to do more than just schedule temperatures, but to be able to improve whatever crap.
Okay. Have you just been filming?
I'll just cut through.
Okay. With our mathematical modeling, we've managed to make EcoStat a thermostat that is able to do more than just schedule when you want to change the temperatures, but is instead able to actually mathematically configure itself to save energy and just be I don't. Why are you making me?
I'll cut out save energy.
Okay. All right. So our mathematical model, which we used to guesstimate the future temperatures and which we used to calculate the R values, is based off some pretty simple principles, but we've modified it to get pretty accurate results. So it's a 3-compartment model. We model the outside as a heat reservoir, and then the inside room and the HC control unit as 2 different thermal objects. We do this because there's often a lag time in which your AC system is turned on and then it turns off, but after it's turned off, the temperature continues to drop. This is like it's a very common thing called overshoot, and we wanted to minimize it. Therefore, we developed a model which could predict overshoot by decompartmentalizing. Anyways, we modeled heat flow between all these regions as proportional to the difference in temperatures, and also between R values. Further, we actually have different R values for whether the fan's on between the HVAC system and the apartment, because that actually determines the rate of heat transfer between the 2 bodies. We actually use this system to calculate our R values via the
Thank you.
Okay. We do it via gradient descent, which basically means we find the slope of our error function and we follow that slope down until we get a valley. And in that valley, I guess you call it machine learning, we find a value for thermal conductivity that would get the same results as the actual physically observed values. So with this, we can actually plot our value over time, and our consumers can actually look at our values, and they can make informed decisions about what to change in their daily habits in order to become a more eco-focused consumer.
With a project like this, there are of course many different ways we can improve and continue to develop it. Of course, we can continue to develop the mathematical models and try to improve and the actual temperature modulation of the project. But there were some other great, exciting ways we were trying to develop it as well. One of the ways I especially wanted to develop was integrating HomeKit into the thermostat to allow people to have the convenience of being able to get all this kind of information through Apple's HomeKit app by default to allow easy use of the thermostat just from a smartphone. And that'll be an area that'll be, I think, really great for the project to continue to develop.